Welcome to the setup and configuration of Multiview on the OmniStream decoder. Multiview is a technology in OmniStream decoders when used with a VCX codec that allow a decoder to join and render multiple streams to a screen with no additional equipment required. This can allow a decoder to, for example, show content in a quad view, picture-in-picture, or a side-by-side view, and does not require additional equipment in the system. Content is rendered in the system based on the definitions of the multi-view at the resolution of the incoming stream. That is, the streams are not scaled in the decoder, which allows the content to be rendered with no impact on latency. Multi-views are defined on the decoder web pages in this new tab called Multi-view. Note that this new tab is only available when the VCX system mode is selected. We provide presets and will walk you through some of the most common ones in this video. Multiview supports HDCP as long as all of the scrambling keys are the same. Though Multiview supports HDR, not all color information can be honored, so we don't advise using HDR content in a multiview image. A multiview is comprised of a canvas containing two or more subframes, where each subframe has the following parameters. Stream address for the subframe video. A subframe is the video IP input, like the IP input 1, IP input 2, etc. It has an anchor point, which is the point on the subframe that is fixed on the canvas. This can be configured as top left, top right, bottom left, bottom right, or centered. The X and Y coordinates on the canvas where the anchor point is located need to be determined. The Z order for the subframe is where the subframes with a larger Z order are on top of the subframe with the smaller Z order. These images show the different anchor point options on a particular subframe. For any given subframe, only one of these will be selected as the anchor point. If the incoming stream changes resolution, the size of the subframe will change on the screen. This is because the incoming stream is not scaled at the decoder. To illustrate this, consider the following examples. The image on the left of the multi-view is configured as picture-in-picture, where the picture-in-picture subframe has its anchor point configured at the bottom right, and the incoming stream is 640 by 360. The image on the right is the same with the anchor point in the top left. Let's see if the resolution of the PNP changes to 1280 by 720. The image on the left grows in size, but the image on the right grows outside of the display. Anchor points will be placed on the canvas at the XY coordinates on that canvas. If the decoder output is not scaled, then this will correspond to the actual coordinates on the display. If the decoder output is scaled, then the anchor points will be rendered on the canvas at the specific coordinates, and then the entire output image will be scaled. Because of the way the VCX codecs work, anchor points must be placed on coordinates where the X value is divisible by 32 and the Y value is divisible by 8. If a coordinate entered does not meet the requirements, then the decoder will automatically snap the coordinates and notify the user of the change. We're going to look at how to set up a dual stream and also how you can use all of the encoders that we created in our solution. The maximum number of simultaneous subframes is 4. A subframe is a scaled version of the same stream coming in from an OmniStream 111 or an OmniStream wall plate, but we can also use the OmniStream 112s. Let's look at how we can create some multi-views with these two 111s and our 112, because you can still use the 112 as part of your multi-view just as you would a full screen with the PIP. We're going to create the three most popular multi-views: quad view, side-by-side, and a picture-in-picture. First, we're going to go to our network planner and add the resolutions of our devices. Now, you'll see I have a second stream for my encoder 111. So I'm going to add the next multicast address. Now, you can also consider the max bit rate. The total is 900, so we have to look at each stream so that it doesn't exceed 900. Let's start with the quad view. The Omni 112 has two 19 by 1080 sources, so we're going to put these in the bottom two quadrants. The other two are higher resolutions, so the 111 is going to be set as a dual stream with encoder 1 sending out full 4K, but we're going to set up a subframe to send out the same content on encoder 2 at 1920 by 1080. And on the wall plate, we're going to scale down that content from 1340 by 2160 down to 1920 by 1080. However, we'll need to bring down the max bit rates on all of these down to 150 based on the recommended bit rate. We have all of the streams already set up. We just need to add the second OmniStream 111 and the multicast of 239.70.0.5. Now, let's set up our first multiview. The default is 2 by 2, but let's name it. If you forget, you can't edit it, so let's call it quad. Next, we'll pick the location of the four inputs. Looking at the dropdown, it might be hard to tell which input is which. This is why that network planner is so important. So let's go ahead and set all of our 1920 by 1080. Input 2 is in the top left. Input 5 is in the top right. Then we have the bottom left. And of course, we have the bottom right. And select Save. Now, just like the full streams, we can look at the HDMI output and select the multi-view quad. Now let's set up our side-by-side. This just needs to be two 1980, and so we can do any combination. So I'm going to grab my computer and my wave. The computer is scaled off the wall plate, and the wave is the first stream on the OmniStream 112. Note the naming. It will help you to know the multi-view and what it's doing, and it will be critical in the control. This name is case sensitive, so make sure you're clear on the name. Now I can switch between my full streams and my multi-views from a single decoder. Last, let's look at the multi-view for picture-in-picture. We want to add our laptop full screen and the camera as a smaller screen. As we get it set up, you'll see that we've scaled the wall plate to 1920 by 1080, but we need it to be back at its full size, and we need the camera to go down to 720. You can see now why we need to make these changes, and this is where we would move into our velocity control system or into a third-party control system using the API. In the next video, we're going to look at using velocity with OmniStream.